Good evening, ladies and gentlemen, and welcome to the 169th event of the Chennai International Center. In fact, in doing the welcome address for the 168th event, I took a pledge that I will not read the resume of the speaker or the moderator because it consumes a lot of time. I have broken that oath today because this resume is one of the most stunning resumes I have ever come across. So, with Dr. Tessie Thomas' permission, I am going to read the main gist of her career, which is an eye opener to all of us. She had a distinguished, outstanding career of about 34 years. She retired in April 2023. I don't believe that. I don't think she can ever retire, considering what all she has achieved and what all her contribution has been in the field of technology linked with missile technology. So, this is a subject which is not only fascinating, but even the common man wants to understand India's position as far as missile technology is concerned. We read a lot in the newspapers, but it's very rustic type of information, notwithstanding a newspaperman sitting here. But to grapple with the issue, we thought it would be good to have Dr. Tessie Thomas, who is really at the center stage of this particular subject, to speak to her in a fairly open and frank manner. Now, Dr. Tessie Thomas is a distinguished scientist, Director General, Aeronautic Systems. She obtained her BTech from Government Engineering College, Trichy in Electrical Engineering, Calicut University in 1985, and ME in Guided Missiles from the Institute of Armament Technology, now Defense Institute of Advanced Technology, Pune in 1986, and PhD in EEE, Missile Guidance from Jawaharlal Nehru Technology University, INTU, Hyderabad in 2014. She obtained MBA in Operations Management from Indira Gandhi National Open University, New Delhi in 2007. Now, this is the crux of her resume. She joined IIT Pune as a faculty member in Guided Missiles in the year 1986. She joined DRDL Hyderabad in 1988. She was associated with Agni program right from its developmental flights. She has designed the guidance scheme for long-range missile systems, which is used in all Agni missiles and underwater weapon systems. An energy management guidance system was designed and developed for the first time in the country for one and all solidly propelled long-range systems, for which she was conferred with Agni Self-Reliance Award in the year 2001. In her work spanning more than 34 years, she has contributed in various fields such as guidance, control, inertial navigation, trajectory simulation, and mission design. She led a major project, Agni 4, as project director for a state-of-art system with many new technologies in the missile systems, leading to weight and space optimization and mass fractions comparable to other missiles of the world. With the development of composite rocket motor, casing, and advanced avionics for the first time in the country. As project director mission for long-range Agni 5 system, she designed guidance scheme for 3-range all-solid rocket system, which resulted in high impact accuracy for this class of ICBM. As Director Advanced System Laboratory DRDO, she held multi-dimensional roles and responsibilities in strategic mission planning and infrastructure developments, and led the development of strategic missile systems. Presently leading the Aeronautical Systems Cluster Laboratories as Director General with the responsibility of design and development of state-of-art UAVs, manned and unmanned aircrafts, aero gas turbine engine technologies, airborne surveillance systems, technology and systems related to parachute and lighter, than air systems for the armed air force. In fact, her resume itself is like a PhD thesis. And the next page is about all her achievements and awards. If I go through that, it will be 8 o'clock. I don't want to do that. But really, Madam, on behalf of the board and the members of CIC, we welcome you. I know it's not a big crowd here, but we always say when the crowd is not big, it's a quality crowd. So therefore, it will be a very qualitative interaction with you. The man to do the moderation is our own M. Ramesh.
Sorry to interrupt. She's also known as Agniputri.
Agniputri, yes, yes. Anyway, I thought anything I left out, you have to cover. You are the moderator because I can't cover. Anyway.
For good reasons.
So M. Ramesh, I don't have a text, I don't want to read out his text. He has been at the forefront of the Hindu business line right from 1994 when the paper started. 1993, the paper was launched in 1994, January, I know. Because I was there at the launch anyway. He joined the Hindu in 1993, but he was associated from business line in 1994. Ramesh is a very different type of journalist. I don't want to get into the nitty-gritty of the biodata, but he calls a spade a spade. He's extremely frank, extremely knowledgeable in variety of subjects. He covers, of course, power, missiles, and various other areas, aerospace and all that. But he is a 360-degree journalist, deals with accurate information, and you can be sure that if Ramesh writes something, it has to be cast in stone. Extremely accurate and extremely correct. So give a big hand to Mr. Ramesh, who has come forward to moderate this session. I am not going to take any more time on the subject because I know nothing about this subject. So all of us are here to learn and listen to Dr. Tessie Thomas. And after she speaks, Ramesh will have a small conversation with her, followed by a Q&A session. Over to Dr. Tessie Thomas.
First of all, very good evening to all of you. I'm really happy to be with the Chennai International Center members and all the members present here. Already Mr. Anand has given an introduction, but I'll start my journey with respect to the frontiers of technology, if you say. From my BTech in electrical engineering way back in 1980 to 85. We had opportunity, I was from Trichur Engineering College, and we had opportunity at the final year to take an elective subject, radar systems. And we were told that we will not have professor to teach you the subject. From our 53 students, only 5 of us were bold enough to take on that subject, because regular professor is not there, then we have to read the book. We know the Skolnick, radar systems by Skolnick. So we have to read it like a Bible, page by page. That was told to us by the faculty. I took 4 other boys and me as one more candidate. We took that subject. And professor used to come from Trivandrum Engineering College to teach that. Since it was not taught, I can say the page by page what it contains even today. That's the way I learned, and our college is also from Calicut University. REC Calicut also was part of it. So I topped the radar systems. That is one of my achievements, I call it, above 90% in radars. So maybe the interest, what I want to say is the interest in you, which would have taught. Like electrical engineering students were trying to take on missionaries, electrical missions and mission design, things like that, where we took some of the people. So it gave me an insight into the military applications of radar systems. And then I was fortunate to be selected for the written test. One among the 10 students from all across the country was selected for this defense DRDO-sponsored MTech course in guided missiles. To be frank, till my age of 23, when I was completing engineering, not much known about missile technology. So by the selective subjects, the applications to track the missiles, all the words, that knowledge came. And maybe because of learning that, I would have scored in that entrance test, got cleared as one among the 10 for the defense course. So the journey of my electrical engineering journey, the track changed. I applied for like any other people for other organizations, but I couldn't even write the test. I could only go for a HAL test, but couldn't go to the second level. Before my result came from BTech, I had to join for this MTech. So that way, just came out of my engineering, and immediately by July, this course started there. It's I call it as fate or whatever it is. I was directed to. I only applied because my eldest two sisters lived in Pune. This institute at Pune, and subject also missile technology would have fascinated me definitely. I joined for the course, learned about the missile guidance, aerodynamics, the control, navigation, propulsion, all about the general course. And then came after the course, we were to be recruited for the DRDO program and came to DRDL. The DRDL is the missile lab where Dr. APJ Abdul Kalam was the director. So fortunate, and I did MTech project in gyroless inertial navigation. So generally gyros is a part of inertial navigation, but I have worked on a gyroless inertial navigation based on a paper published where we can get the information of gyroscopic output by using a signal processor unit by separating out the rotating and non-rotating. I don't want to get into the technical details of it. And then that's the thing when I met Dr. Kalam. I still remember the day I joined there. We all the students are all the young scientists are called by the director, and he asked what I have done as my MTech project. So what he said is here 50 odd scientists are sitting and doing inertial navigation with gyros. Why don't you go and teach them that gyroless inertial navigation possibility? I really felt, the proud moment for me that I have done a great job as MTech project. But it's not that. I mean, at that age, you come as a postgraduate and you feel great in what you have done at that point of time. So that is the way Dr. Kalam used to inspire us. I joined the inertial navigation group where I learned the navigation, guidance, control. All of my journey started from there. This is way back in 1988, Feb. The learning curve starts from there. Till then, book reading, the knowledge is there, but practical implementation or practical knowledge starts from there. Being a scientist, we need to acquire knowledge. Whatever we have learned is at very low level, but reading and updating knowledge, scientists every moment has to learn. That is the thing what is being told to us. You can't be satisfied with what you have learned. You have to think about. That's the way we have been nurtured by great leaders like Dr. APJ Abdul Kalam and all the further senior people. Never give up. So I have never given up in my life of reading and learning. As on today also, now it is very easy. You take your mobile, you scan it, you will get knowledge. That's the world we are now. I'm talking about a world where we didn't have all this. You have to, after the office hours, we have to go to the library, read and learn. That was journals, science journals. That was the time when the knowledge was not there. Like the area in which we took 1980s, when IGMDP program, the Integrated Guided Missile Program, again totally formulated by Dr. APJ Abdul Kalam, the 5 missile programs was taken up, and we were into the technology development. That was the time when technology denial, that's nothing of neither electronics nor manufacturing capability, say anything. We didn't have anything at that point of time. So we started from the very beginning. We have 5 types of missiles designed that time. And missiles again classified into 2, the tactical missiles, that is for a short range application, wherein which we fly for 300-meter interception to 300 kilometers capable. That comes under the tactical class. Then the long range 300 kilometers to 5,000 kilometers, the long range missile class. Based on the role of application, like surface to air, if it is to attack an aircraft or an incoming missile, air to air, surface to surface. So Agni comes in the surface to surface against moving target. All this application based on where the platform from which it is launched, and the ship against a ship, and the tank against a tank. So these different classes of missiles comes. So as sir read about me, that from the very beginning I was into the inertial navigation group, and we started working on Prithvi guidance, where surface to surface, and I was chosen for the Agni development, where we started working on a guidance scheme for the Agni demonstrator system, where a rocket motor in the second stage we used a liquid propellant system, wherein which we have the capability to terminate the thrust. That means when a liquid oxidizer or the fuel, one of the supply is stopped, the injection valve is stopped, the burning stops and the energy imparted gets stopped. So you can terminate the propulsion system with that and then go as a ballistic flight beyond. So when we say 1,000 kilometers, I may need a velocity requirement of 3,000. I'm just taking few numbers, it's not relevant numbers. 3,000 meter per second. Very accurately we can terminate at that, when the missile achieves that velocity we can terminate. So that was the technology available till then. Space launch vehicles also used to have this liquid based systems. But when we look at that type of systems as a field worthy, like taking it to a user site from military operations point of view and keeping it stored for years, it's the liquid fuel and the oxidizers, they are highly corrosive and harmful to the hazardous to keep. And the control system or the type of system what we have, it's bulky and storage and last minute filling and charging operations, it has to be charged to very high pressure. All this is a concern, and the complex operations of it was a concern for. That is where we were asked, how do we work on guidance system for a solid rocket. Solid rocket system becomes compact in size, so that it can be stored for years together and field worthy and can be used. But solid system is again like a solid rocket motor is like if you burn a cigarette from one end, it burns from one end to the till the end. So solid propulsion is again like that. Once ignited rocket motor, the whole energy comes. That energy has to be managed to get this guidance performance or the trajectory performance. When I say the Agni class of missiles, it has a range capability. I will talk with respect to Agni 5. If you take from 3,000 kilometers or 2,500 kilometers to 5,000, one single mission, that means the system is ready, Agni 5, it can cover any range from 2,500 to 5,000 on board. So you don't have to do anything. You have to give the coordinates for those ranges and do that. How was that possible? That is the 3 stages of rocket motor was coming. So that is where the statement energy management guidance. So from a solid rocket motor, how will you manage the energy? That was the work put on to me to make a development of a guidance system. It's based on mathematics. I don't know, God-given gift of solving equations that from my MTech thesis onwards. Again, Jarolus, that also has a lot of signal processing equation solving. If you ask me to do that now, probably I may not. That time as a student, I had taken it up and completed. So the interest in solving mathematics. So again, Earth is rotating, and the corrections, Coriolis corrections, and the travel over Earth. All this mathematics part understanding, and I used to revolve my own head also to get the things. But because these are knowledge which was not any book given. Book gives the fundamental equations beyond which we had to develop the guidance scheme. That is how I developed the solid propelled based guidance scheme, energy management guidance scheme. From the energy available, I can take the missile, or trajectory shaping or the guidance can be done, and the missile can be navigated and controlled and guided to that particular trajectory. When we say Agni 1, 300 kilometers to 700 kilometers capabilities. Like then Agni 2, we say 800 kilometers to 2000. Agni 3, we established from 1500 to 3000 kilometers. Agni 4, we established up to 4000 kilometers, 1500 to 4000. Then Agni 5, 2500 to 5000 kilometers. So this journey has first part is designing the guidance part. Then the first work was on the Agni 2, then the Agni 1, Agni 3. Agni 1, 2, 3 is one particular class of missiles where we have metallic rocket motor casing. This is where the mass fraction comes. Till that time, if you look at the world across, Agni 3 has a launch mass of 50 ton. 50 ton is the launch mass, and it reaches to 3000. World across was taking these systems to 3500, and nobody gives a exact number and capability. It will be reported something as newspaper reported. This is where I was asked to look into that how can we achieve world-class missiles. So I was designated as project director for Agni 4. That's where we built on to that. Agni 2, look into Agni 2 modifications and reach it to a capability. So I started changing one stage. It doesn't meet the requirements. So the composite, the world across was totally going through the literature. They talk about composite rocket motor casing. And our country didn't have that capability at all. The carbon fiber is not available. NAL started designing, and that the grade carbon fiber for this aerospace applications were just getting developed. But it was really a challenge. I didn't know what type of responsibility I was shouldering when I was asked to take the Agni 4 as project director. Started working on the stage rocket, composite rocket motor casing with carbon fiber combinations. And second stage of the Agni 4, we'll find the color difference. Then now it can be of any color, the black color, it will be carbon fiber color. The system was first time developed, and the weight benefit what we got out of this composite rocket motor casing is like 40% weight benefit. And but by changing one stage doesn't give us the total thing. So I was given the freedom as a scientist to see the total missile from tip of the missile to the bottom of the missile, that is base road. We took the reconfigured or redesigned, and with 22 ton, that is less than half the weight of Agni 3. Agni 3 was 50 ton, and this is 22 ton, and we could get a range capability up to 4000. So that is one stage of rocket motor, but the total technology inside, everything has been changed to new digital. The full freedom of working for the changes in technologies was taken, and we built Agni 4. Then it is adaptation of this technology into Agni 5. By the time Agni 5, 2 rocket motors were changed to composite, and with the 50 ton, from 3000 we reached to 5000. So that is the way the technological advancements happened in these systems. So I worked there as Agni 4, Agni 1, 2, 3, all through I am there as mission design, and we take a paper and draw the missile. Then I can say, by sizing, I can say what range it will go. So that is the way we slice and configure the missile stages, how many rockets are required, rocket stages are required. So they're all configuration design and mission design, trajectory design. That's the way the technology has evolved. So Agni 5 gave the 3 stages of rocket motor. Again, the guidance system, guidance design, what I have done works for any class of long range missiles, which can cover any range. You need to give the where from you are launching, the launch point coordinates, latitude, longitude, height of the from where you are launching, and where it has to hit. So there also latitude, longitude, that solely is enough. Rest all the missile takes care. On board, explicit solution for the guidance. So that is how I became so close to the Agni and the Agni missiles and guidance systems. Then I was given the responsibility as director of the lab, wherein which all this Agni class of missiles and interacting for, of course, a part of the missile complex. We have been working for all class of missiles. And then this same philosophy is adopted for all long range systems. Then after working as director for all systems of Agni, I moved as director general to Bangalore for aeronautical systems, where the fighter aircraft, indigenous fighter aircraft, Tejas design, when I went there, it was at the final operational clearance, got through the final operations clearance, and now it is under production and HAL is manufacturing the systems. And I was part of the HAL as a board member, being from being the director general of that. So I used to tell HAL that I wanted to write the exam and get into HAL, but I straight away came as board of directors. So there also I applied for HAL, again aeronautics. Finally landed up looking after Tejas. My son is named as Tejas, way back 30 years before. So that is, and my son was named Tejas. Afterwards, only the aircraft was christened as Tejas by then Prime Minister Atal Vajpayee. So that's somewhere. Now people say mother of Tejas. Yes, aircraft or either way. Then I thought the missile technology is the top technology, which is difficult to solve and things like that. When I came into as taken the responsibility of DG there, we were working on unmanned systems and fighter aircraft also, because human pilots are involved. The life and the safety criticalities are involved. Lot of the avionics what goes into the fault tolerance systems what we built into, because missiles are single application but very critical. They are nuclear capable systems, so we can't fail anyway. And missiles, it looks 15 to 20 meter length. The number of cables that runs into kilometers, more than 10 20 kilometers. That is the type of systems we handle, and the number of connectivities, connectors, pin. One single pin count, it runs into 10,000 pins and all. And one connectivity comes out, missile is out, the failure happens. So that is the criticality of those class of systems. When it comes to fighter aircraft, it is still more safety critical because human beings are involved. So the logics and the safety logics and interlocking systems what we provide for fault tolerant and redundancy wise, not double or quarter redundant, 4 times type of redundant systems are put in. That is where I understood that technology is still tougher than the missile technology. Then came the unmanned. We all hear about drones. I'm not talking about the small ones. I'm talking about the military drones, which goes as high as aircraft height and do the surveillance. It can be weaponized. It is all kinds of applications. Similar like missiles. It can be used. Then airborne early warning systems, which fly well above aircraft height and observe with their radar capability any incoming systems. So that is the field wherein which I worked for the last 5 years. And now I am a retired scientist. 30th April. I am very happy, celebrates the retirement part, because my son, I just wanted to share with you all. I have 36 years work experience. My son says you have to multiply it with 1.5 times. I can live all strength, everything we mention in terms of 1.5 times. So mama's work schedule, considering the time of our work, it is not 36 years of work. It's something like 50 years and plus. So that is the journey of me with respect to the technologies and all. Now I'll leave it to Mr. Ramesh to further and I once again take this opportunity to thank the executive members of Chennai International Center in giving me the opportunity to be with you all and share my experience and the technology what I've seen through. Yes, it's a wonderful world. Like we started with 8086 based processors, where we started programming on a assembly language, and now Agni series have gone through 286, 386. By the time we develop the system, it is out from the. So we have to move along with the technology, 386, 486, Power PCs, system on chip, and the speed in which, as the trajectory simulation to give us 6 degree of freedom simulation runs, we used to put it on the job and come back next day to see the compilation. Or so that was the type when we joined way back in 85, 86. But today it is faster than we in between gone through the real time system. Real time is also not in which it's faster than fairies, what we call. So the computing power, the memory capability, and the onboard estimation, that gives us the credibility to go into the systems, more and more work on the AI based systems. When it comes to unmanned, lot of artificial intelligence based estimation techniques gets into. That is the way technology is growing, and present generation is really blessed to get all the technologies, the knowledge in front of them. They need to learn, and practical applications are, you can understand. When I was in school days, I have never heard about missile as a projectile. Maximum to extent was the knowledge, but today I can say we are self-reliant in missile technologies. Thank you. Thank you for the patient listening.
As she was speaking, I quickly Googled gyroscope-free inertial navigation. Okay, this is what it says: a gyroscope-free inertial navigation system uses only accelerometers to compute navigational trajectories. Got it? I didn't understand, but also, so that is what it is. That is what she's been working on. Oh my God. Well, I can tell you.
36 years before.
Yeah, That was back then. Well, in my 30 years, 35 years of professional experience, I've interviewed a number of people, talked to a number of eminent persons, and I can tell you, I rarely have I felt that kind of thrill that I'm feeling today, honestly. So, otherwise, meeting people, talking to them is a commonplace thing for me, but today it feels very different to be talking to you. So, let me start by asking you some questions. How is life in Patna?
Patna. Why Patna? That's what
How do
I
you
was
find life? You spent 30 years in Patna. How is Patna?
You have to
You
tell.
were all thinking that she's from Kerala, I'm talking about Patna. Have I lost my marbles? Well, Patna in a different, you want to explain?
Yeah.
Patna in a different context, in the context of missiles, stands for, it's an abbreviation for Prithvi,
Prithvi,
Agni, Trishul, Nag, and Akash.
Gosh. Yeah.
She spent her working life in Patna.
Yeah, yeah. Now only I have realized that. Patna is known to me now only through you only.
So I didn't mean the city. So I have not yet lost my marbles. Maybe I will when I read about gyroscopes. So these 5 missiles, Patna missiles, form the core of the integrated guided missile development program that was started by Dr. Kalam. She joined pretty early in her career. Here the key word is guided, an area that Dr. Thomas has worked on. Now, I basically understand what guidance is. I mean, you can tell the missile where to go, where to turn, where to go. That is basic. But a little beyond that, what exactly is it? I mean, can you give us a look and feel of it? How do you tell something that is flying there to take a right turn, a left turn? What does it mean? What is a guidance system?
Yeah. We have guidance system which consists of, it's again not, if you look at it, it's an onboard computer, wherein which we have the guidance algorithms, we have the control to execute the guidance commands. Control commands, again, we have to have executed through actuation systems, which really moves the control fins or the real command to take on. So it consists of all the 3 of this, which work in tandem, one after the other. In case of tactical missiles, like Akash and all, we have to have it is from surface to air. It's against an incoming missile or an aircraft. So we launch the missile, and then finally it has its own radar systems which will lock onto the, based on active or passive type of guidance can be there. And it, like an interceptor, it will locate the aircraft, incoming aircraft, and based on the location known, it generates the homing system, like line of sight, it establishes and goes on path to go and directly hit. That's a homing guidance system.
You need to be giving it instructions.
No,
Sitting
it's on board. Like on board, it has its own navigation systems to say that where it is. Where am I? And I have to go and reach there. And a direct line of sight courses, the trajectory is defined, which we call it. So deviating from that, if the missile is not going exactly as per the propulsion systems, that error corrections is given through the control. So it finally, a closed loop feedback where you are, and it reaches, and it has the homing guidance. It has where you have to home. It sees every instant, it sees the target, and it homes onto. The word homing is going and hitting through the active radar signals. The radar gives the update, and the target is here. It's a moving target because being an aircraft. So it keeps course correction, line of correction, and that is where the guidance for that tactical class of missiles is done. Whereas in the case of Agni, it is the inertial navigation, wherein which, as I mentioned, gyros gives the angular rate, the body rate of movement of the system, missile, and accelerometer senses the acceleration, which we integrate to get the velocity, again integrate to get the position. So accelerometer gives us the position finally. From acceleration, we calculate, onboard calculation and get the position. And the angular rate information from the gyroscopes, we integrate and get the attitude, the angle at which it is to move. So that is how the positions 3 vectors and the angular 3 vectors, the attitude vectors, totally 6 degrees of freedom. That is pitch, yaw, roll, all the 3 movements plus the positional change. Together, if you know the 6 degrees of motion of the missile, it can be, that becomes the trajectory, it can be moved. In Agni class of systems, it is done on board. Every instant, we have the computational capability. We started with 100 milliseconds computations and came up 1 second computation to 100 milliseconds. Now even 1 milliseconds you can update. So that is the computational capability we have today. And every 1 milliseconds I will get the missile position as well as the target position. So trajectory is defined. What is the optimum path? The calculation, guidance equations does the calculation. How can I reach this path or this path, depending on the range. If it is a long range, it assumes a shallow path, longer distance, lesser altitude, and climbs less altitude. If same mission with the rocket, the energy management part is done for a lofted trajectory, a shorter trajectory, it takes a lofted trajectory. It computes and takes, it goes up and then comes down, dissipates the energy and reaches down. So that is the guidance system.
Okay, I can't say I have understood everything, but I am guided towards it anyway.
Yeah.
No, but
And it is not detectable by, like, inertial systems or radars can't see the inertial part of it. It doesn't emit anything, like, unless like homing systems and all, the radar present in it can be known by another
is the
radar.
homing optical or
In IR based also you can
IR
use
based
IR based.
So then the target should be radiating IR.
Yeah, IR.
Only then you can.
Then you can. So the multi, both dual mode seekers will be available, like IR or the homing, both.
Okay, so
Both are
equip the missile with everything
yes,
that
yes.
it needs to do. Okay, that's a key point. And today we are talking of this multiple re-entry. So you can guide each one of them after it leaves the mother.
Yes. That is launched in the MIRVs. When we say
Yeah,
single
MIR.
one, the payload portion, the RV vehicle, the topmost one, it is released with the accuracy to go and pinpoint the target.
So 4 are released and
4
can
are
go to
released
each.
at a different altitude. That's on-board computation of releasing. So it's possible.
You make it
See,
sound so simple.
like what I mentioned is that guidance has that much of calculational accuracy. Pinpoint, we have achieved less than
You make it sound as if
single
it's like
digit
cooking rasam at home.
accuracy. So the on-board calculations are that. So that is that's the greatness of the guidance equations.
Very hard to imagine. Anyway,
Even like we say 1 meter per second velocity error, if you land up, the missile will be off by 4 to 5 kilometers. But we have achieved accuracies of single digit meters. That's our capability.
so if you want to hit here, you will hit here. That's it.
And nuclear
Really
systems.
remarkable and very heartening to note.
Textbook
We have
launch,
done
we
it.
call it.
We've done it.
Have achieved it. Yes.
Okay. But we've been guiding rockets, where exactly it should, which spot in the orbit it should go and all that. So is there a big difference between the rocket telemetry and this one?
Yeah, the guidance schemes are different in the sense, for a missile it has to go up the atmosphere and come back on the re-enter back on the atmosphere and hit the target. The technology what we used for Agni's success was first the RVS structure, the re-entry vehicle structure with the carbon composite, carbon phenolic for the temperature protection and carbon epoxy for the structural strength. So embedded structure of that composite structure development first time in the country. That is why we could have the Agni class of systems.
So is that the key thing? That is weight reduction achieved by using composites and carbon fiber?
That
Is that what got the range?
No, that is the re-entry part, structure. Rocket motors became composite casing. That became the
Rocket casing.
casing.
It
The
changed from
stage
metal to
rocket
non-metal.
motor. Yes, metal to. Metal, we started with the maraging steel, 15 CDO6 steel to maraging steel, 20% weight reduction. Then came the composite. It is again a technology involved with 15 to 20 years time.
Do we have these raw material and components within India? Are they indigenously available?
Yes, it was tough to get this. As on today, we are indigenously developed.
So we can make the whole system ourselves.
Yes, yes. Agni is all indigenous. If you talk about Agni, nobody gives. 20 years, nobody knew that Tessie Thomas existed in DRDO to the outside world.
That is why you could get that. Now we are talking of even more advanced systems. We are talking of Agni 6 and Agni Prime that was in news last month.
Yeah.
I don't know to what extent you might want to speak about that.
No, it's
But what
like
exactly is it?
It's a variant. We have Agni 1 capability, Agni 1, 2 ranges up to 2000. This single system will give the capability of Agni 1 and 2. That is the way.
Just another
It's
question.
again a composite, all composite it is, two stages, two-stage composite. We get the benefit of the weight reduction and get the range capability.
Can ballistic missiles also be guided? I mean,
Yeah,
my
that is
understanding
Agni-
of ballistic
Agni is
missiles is
ballistic
just take it up
missile.
to this point and drop it there. It goes, no, it doesn't. You drop it at that point, from where it will fall onto your target. That is my understanding of ballistic missiles. So
We have a re-entry. After re-entering the atmosphere, again it can be maneuvered also. Guided at the till the
So
end.
both
Or
cruise and ballistic missiles can be guided.
yes, yes. Cruise missiles, we call it cruising at a particular altitude. Like we say it goes to generally subsonic cruise missiles and all. They cruise at an altitude of 3-4 kilometers or 6, maximum up to 6 kilometers. So that is a different technology based on small turbofan engines and cruise it to 1000 kilometers. So that technology, and it can be again a homing system to hit the target. Guidance is based on homing and directed to the target. Whereas ballistic missile, as I mentioned, it's inertial based. It travels depending on the where I am, where I have to move. Every instant it computes and trajectory is ready. At this instant I release, I'll reach here. That is the way it is
So
always
you
connected.
still guide
Yes.
it, steer it. to
Yes,
its target.
yes, yes. The control systems will take care of the guidance command. You have to move this way. That is corrected through this control commands. Whatever feedback comes, if it is not corrected, next instant it gets corrected. That's the way it defines.
Well, I broadly gather that ballistic missiles are supersonic, but do we have supersonic cruise missiles? BrahMos, I think.
BrahMos is the first
supersonic
of
cruise
the
missile, but
kind supersonic cruise missile. It's again based on a ramjet engine, supersonic ramjet engine. It again
it's a
like
ramjet engine, not a scramjet engine.
no, scramjet is for hypersonic.
Hypersonic. Do we have hypersonic? By the way, all of you would have read that Iran developed a hypersonic missile. It gives us jittery. They may not be enemy country, but still.
We also have demonstrated the technology capability. A country needs to have the metallurgical advancements like hot structures because it has to cruise for hours together. The temperature generated in this type of engines of the order of 2000 degrees and more. So you have to have hot structures which will withstand this temperature. That is our.
So
we are into.
we have
We have demonstrated. 2 flights have been successfully
So
demonstrated.
typically, how long does it take from demonstration to induction?
It's on the projects within 2 to 3. Today, as on if you take 2 to 3 years time, development cycle. Yes, that's all.
So we are not very far behind.
No, not at all.
Thank you. Ma'am, can you tell us about the technology denial that you faced during your, and how you overcame that? What,
Yeah.
I mean, we hear that Germany denied us magnesium alloy.
Yeah.
France
That's
denied us
again a
accelerometers
structure.
and so on and so forth. But
Yeah, magnesium alloy gives the benefit of structural weight reduction plus more stiffness. So it is basically used for automobiles as well as aerospace applications. Once anybody comes to know the size of the magnesium alloy, what we are asking and all then they'll get to know that it is for this strategic importance, and that's
They pull
where the
back.
denial, yes, it happens.
So what
Like
were the
aircraft
instances
structures,
of technology
aero
denials?
engine
Yeah.
elements, this we use for casings, compressor turbines, turbine blades. We use magnesium part, alloy part. So that is why titanium or this, they're all
So
doesn't
again,
come
sorry
in
to
that
repeat
bigger.
my question. So did you face instances of technology denial, and
Yeah, it
how
was
did you
very
overcome
difficult
that?
initially to get the structure materials for missile application was very difficult. That is where DRDO, headed by the leadership of great visionaries like Dr. APJ Abdul Kalam and all, way back in 1980s, the programs were initiated, and we looked at the industries to develop aerospace industries to start getting it. Initially, maybe some amount of bringing it from there and knowing the material. We have a DMRL laboratory which works on the materials. So the development of these type of alloys, Maraging steel is a indigenous development by Midani and DRDO. So like that, the process of involving by now 30 years, we have established our own indigenous materials for this same capability. That's why composites also came into. Now, carbon composite is another like LCA and all, more than 50 to 60, 70% composite components have come. So that way, the weight reduction, that's how the lightweight LCA, light compact aircraft.
So we
this-
developed all these ourselves
Yes, that's the,
in the face of denial.
yes, in the face of denial. And when we are put to, only we work for it, and that's how the industry has grown. And
So can you say today that we have a complete grip
self,
over this?
yes, self-sufficient with respect to what all this technology is established.
Except perhaps the Tejas engine, unfortunately.
Yeah,
It keeps
aero
little
engines,
legal.
yes, aero engines. What I am basically saying on the structure materials, the aero engine capable to withstand this high temperature for long durations. And fighter aircrafts comes this application for flying for long durations. That is where we lack in that. The technology also, we are on the development of such systems, the Kaveri engine. Outwardly it looks, but we have mastered the technology, the capabilities to certain level has been established. It's under production, it's under manufacturing within
Is
the
it
country.
ready to be used in a Tejas? Kaveri.
Tejas, it has an underperformance. So
Yeah.
the engine capable to what material we are indigenously developed. There's a difference. But that technology gap will be covered in another few years.
So
time.
just a hop away,
Yes,
not too far.
not
So
too
we've still
far,
come.
not too
Okay.
far.
I suppose it takes time for
Yeah,
us to develop.
because we don't have the such manufacturing industry to take on this. You can't machine the size of such uh, forgings to this requirement. Today, industries are getting established to that size and that magnitude capability. Once that is done, we'll be able to take on.
Well, on this count, I'm just reminded of something that one startup, Chennai-based startup, incubated by IIT Madras, told me that they can indeed develop an engine for Tejas. Of course, it's a claim at the moment, but we will see. So,
Yeah,
as
yeah.
you say, we are not
Tejas-
too far. There are
Tejas engine
capabilities
can be
built up.
developed beyond doubt.
In some about the missile program, so of course you spoke about it for half an hour, I know that, but still, how would you sum it up? And how are we today with respect to, let's say, without naming any other country, how are we? Are completely surakshit hain?
Yes, we are self-reliant,
Completely. So we have,
self-sufficient, and high accurate systems.
what would you say about anti-missile dome that we have, anti-ballistic
Yeah,
cover?
anti-ballistic missile also we are well established. India is one of the countries where from the first demonstration, first flight trial onwards, we have been successful in hitting the target.
So I believe we are one of the 4 countries in the world to have this.
Yeah, but we were first attempt to all the flight tests what we have done, we have hit the target on spot.
So interceptor missiles.
Yes.
Wow, that's really wow. Let's move out of this a little bit and slightly onto other subjects. What were your most memorable, happiest instances that you came? The most memorable instance, positive, and which was the worst?
There's nothing.
The order is yours. You can choose any order.
There's nothing worst. I always take
No, something like when a
risk
demonstration is
or
happening, you kind of
challenges as opportunities. Because being a scientist, we go through failures, yes. And Dr. Kalam, fail means first attempt in learning. So we are doing first time. We are not knowing what we are doing. We don't have the technology around. We don't have what we want. We will not be able to get. Then we do something to establish something, to achieve something. So when we reach the final stage of achieving what we intended, that gives the best period. And nothing is worst.
Do you
We have
recall an
learned.
anecdote, a story from your life that is worth mentioning here?
No, like
Once upon a time,
once upon a time, like a learning curve from our Agni 3, the first launch of Agni 3, we faced, I won't call it total failure. The flight went smoothly up to 70 seconds. The trajectory, we have mission console showing the trajectory. A perfect overriding performance. At 70 seconds, suddenly we see the missile is tumbling and falling. So this is something sitting in the console, the shock waves. Heart breaks or survives, we don't know. But it is equivalent to a heart attack goes through. And we couldn't make out, because if a missile is failing, there is a symptoms we'll find. But in this particular one, absolutely Agni 3, we are all cheering up, suddenly the missile is dropped. Being a mission person, I'm with the trajectory and looking at that. And as I mentioned, I don't know whether my heart stopped or revived again, God only knows. That the learning curve from that is we came back, seen the system, and control failure happened. But how it has happened, what triggered it, what first stage rocket motor is only burning. The knowledge, like we changed from Agni 2 and 1 is 1 meter diameter rocket motor. Agni 3 becomes a 2 meter rocket motor. So our knowledge with our capabilities.
what is Agni 5? What would be
It's
diameter?
again 2 meter,
2 meter.
diameter. So first stage rocket motor. When we cross the atmosphere, the moment it goes rarefied atmosphere, the missile plume, it expands. And what exactly happened in Agni 3 is the plume volume is more, it expanded, and in the rarefied atmosphere of 18 kilometers, 20 kilometers, it expands and it folds back. And mainstream flow is there, it mixes and folds back. So in that folding back, the hot air entered into, we have a flex nozzle control system. Being flex nozzle, we have to provide some space to flex it. 50 mm space is given all around the base road. And the hot air entered that, and maybe one of the cable, what I mentioned, would have got burnt, and that's the end of it. So that is where. But the knowledge gap, what I wanted to say.
This was the problem with that one.
Yes, the knowledge gap.
How did you find out this was the problem?
Like we had our simulation facilities, whatever we had. Those times the computing capability was not as great. So we do not know every millisecond what is happening, the flow expansions and what time. So that knowledge gap has given us the problem, but it's a learning curve. So once we simulated with the higher end computers, we had to get through and...
No, but 1 minute. If the plume folds, it folds. What can you do about it? How did you solve it?
Then the plume folds, but that knowledge of when it moves in the rarefied atmosphere with the 2 meter dia, we have not seen
1 meter was not getting back into the system. The 2 meter with the flex nozzle was getting. So we have made a composite shield, heat shield, composite shield, which will also flex along with the missile. That within that 50 also, the shield was provided and it flexes, so that thereafter no plume
So
enters.
let it fold, who cares?
Yeah, let it fold, it goes, but it doesn't enter the missile.
Okay.
So that is one aerodynamic and control interaction.
No, these Agni
Flow
missiles,
interaction.
when you actually do the longest range, what is the altitude it reaches? I mean, we hear of North Korea doing up 2,500 kilometers. It doesn't have
Yeah,
to
it
be.
can.
My
Five
thinking was
also
it
can
go
go.
up suborbital only.
It depends on the trajectory, what I said, lofted trajectory, it goes high and comes to a shorter range. And shallow trajectory, it will travel at lower
So it's up
altitude and reaches. That's the mathematics, as my guidance says.
Well, no more about that, please.
Energy management, what I said is, missile does this.
I know that mathematics has something called algebra, but beyond that. Anyway, ma'am, we talked a lot. Very interesting.
Yeah.
Now tell me, what is Dr. Tracy Thomas as a person? See, we do see you as a very traditional person. So how are you as a person? How are you at home, at your kitchen? What do you cook?
Yeah. I am saying
Your
Tracy
faith,
Thomas.
if you don't mind.
No, yeah.
How often has faith helped you in your journey?
Yeah.
If you don't mind answering these questions.
Like any other human being, I am also a lady at home who's a wife,
You
mother.
are not any other human being.
And a daughter looking
Rare
after
girl.
mother. My mother used to stay with me, so I was fortunate to have her blessings all through. And as a mother, I've looked after Tejas. And
You have 2 children named Tejas.
yes, that is mother of Tejas. And I like it is difficult, like working hours, to be frank, for this particular field of work. It is not 9 to 5 p.m., 9 a.m. to 5 p.m. It goes beyond, because we are all working for technologies which has to be established first time. Be it, it's not a repetition. It's as I mentioned about technologies keep changing. Everything we started with the analog systems, controllers, to digital, fully digitized, 1553 bus architecture. If you take the avionics part, a vast change, totally from that to this. So every time when we do a test in a missile, we will be going through more than 5,000 types of tests in missile preparation. Each missile is unique. Not that one made, second one can be taken because of the criticality of the operations. We have to go through the same iterations and preparation of the systems, testing and proving, simulations and all. Once we start the test, it goes through, I said, more than 24 hours sometimes. So we need to be there with the systems, being a project director, technology director, and the working group. More than 100 to 200 people will be there, almost moving around in and out. Like we all have working lunch or working dinner, or have dinner, come back. There's a shift like. So that type of life also I've gone through. So it amounts, like when we come back home, I take the role of my...
But work-life balance in your case must have been more difficult than that of a working woman.
Tough, it was tough when my son was in the 10th and 12th time. I had to get up at 4 o'clock. He used to go for his coaching, so-called, because it is mentally in the thing that his son has to go for engineering, and he went for engineering. So that 5 o'clock sending out him for his coaching, that was because I would have come back at 11 o'clock, 12 o'clock or 9 o'clock, morning, getting up, making his dabba and sending all those. It's like a routine, like circus, Univille circus we do. Uni wheel cycling we do.
What about faith? Are scientists also believers?
Yes, very much. That's why I said each launch. I have gone through more than 50, 60 Agni missile launches. Sitting in that console and going through this, we have to call. Whatever we do prepare, we have to call our God. Finally, it's what it each launch and all pujas, everything we do, because it is finally we have done our part. Tan padi, devam padi. No, like.
So he seems to have done his part also in this case. Thank you. All right. Well, I have just another 100 more questions, but I will stop here. Now we throw the questions open to audience. Just a couple of things before we start off. One, she is just retired, and it's a very strategic position. She may not be in a position to answer all the questions. So while you may ask your questions, it may not be wise to persist for an answer. Sometimes if she does not want to answer, it is for the good of all of us. I don't need to tell you people this, but as a matter of protocol, I'm saying this. And the other request is, the briefer the question is, the more question we can have. Please go ahead. Yes, sir.
Thank you. It was indeed a great session for me after long, I did my engineering. Sorry. My name is Ganesh. I work as a head of analytics for a private concern. Ma'am, before I would like to share some information I know. This carbon reinforced material, in this one of the interview, APG sir said that this was used for, people with differently challenging people to bring the, the light-weighted, what you call
Jaipur food.
Yes,
Yeah,
Jaipur
we used,
food. Yeah.
that
So that is one of
FRP
the way.
materials.
Yeah. And the common question I have is, what is the chain of command if I have to, launch a missile? We have not done it, but what is the chain, as a common man, what's the chain of command you go through? Some say, Putin has a, button under his.
Yeah, it is finally a button pressing only. But yes, and we give it to the, it is inducted into the army and the tri-services. It's again the command chain is there. And strategic systems, it starts from our highest authority, Prime Minister, down. So that clearance comes. It's again a government policy, guided policy. For strategic, it is different. Tactical, it is the services takes the command in chief takes the decision to go ahead.
Ranga, go
That's
ahead.
our government policies.
Go ahead, Ranga.
Good evening, madam. My name is Rangarajan, where I run a very ordinary, simple software company, and compared to what you do. Okay, so when I came in, I was thinking that, somebody who's built a missiles and all that is going to be a very aggressive, tough, for lack of any other word, macho person. And when I came here, I was both surprised and disappointed. Surprised because, for somebody who actually builds something like this and keeps all of us safe, you seem to be remarkably calm as compared to, let's say, we get hassled by, one software not working and all that kind of thing. So, is there, what's the secret behind your calmness? It seems extraordinarily calm. I don't know if I'm the only one noticing,
that
but
may be outside. Probably I'm a tough lady. As a project director, I would have been tough to take on decisions. It's again, we have to have an intuitive spirit, mind to take decisions. That toughness, sometimes people say iron lady, that's also. Then you have to have the technical knowledge to argue, or other people have to accept you. So you have to have your own technical knowledge. Then only people will accept you. Actually, I say gender, science has no gender. The knowledge, what you have, speaks about the person. So when I became project director, I was at scientist level, very junior, compared to generally project directors, the senior most gets. then it was really challenging to get work done from seniors, asking them, you do like this, do like that. It was tough, but that's again, people could accept.
Would you yell at your subordinates sometimes?
Not yelling. Yelling doesn't help here. It is, you have to be patient. Perseverance is something you can't give up, because when I took over Agni 4, development of composite rocket motor, nobody wants to touch the technology because it's not proven, it's not, even the carbon fiber was getting in very few quantities. Establishing it as a rocket motor casing, going through the proof test, high pressure test, we took a period of 4-5 years. So the churning and the things, people without giving up and getting it done was something. And like we have, we won't relieve it out till we establish. So that way, keeping it under the shadow and then working for the technologies, first of its kind in the world class. If we Agni 4, with that we established the technology totally. So world class. So that.
Go ahead, sir.
Hi, good evening. My name is Shekhar. Extremely fascinating session, Dr. Thomas. I work as a project advisor at IIT Madras. Now, a couple of questions. You can choose to answer one or two. You talked about propellants, solid fuel propellants,
Yeah.
3 stages, multiple stages. Did you consider liquid propellants, and did you have any challenges with, say, cryogenic engines, etc.? That's one. The second question is, how do you test such long-range missiles for accuracy? You have launched, and obviously you should have expected to land somewhere. Is there a chance that it may not find the destination? Will there be a problem? I know we launched from Chandipur on sea or something from somewhere there, but how do you actually demonstrate from simulation?
Yeah.
So thank you, thanks.
Yeah, first question on the liquid. We started with the technology demonstrator with the second stage, a liquid rocket motor. What I said, the complexity has taken it. As you asked about the cryogenic, it is basically not used for missile application. Cryogenic, again, storage at minus 273 degrees Celsius, and it has high impulse, long duration, like for space missions. For missions of that long periods travel, they use a cryogenic, where the upper stage is used for the cryogenic. It goes on flying for hours and hours. So that is where the cryogenic comes. But missile, the bulkiness, the 1 kg extra will lose, I lose almost 3 to 4 kilometers. So we look at milligram level of carrying the weight. So there is no huge systems is not looked at as. That is where the weight reductions and weight penalties comes. So any extra 1 kg added, I lose almost 4 to 5 kilometers range capability goes away. So that is where the solid rocket motors are looked at, compact, and gives the high energy to reach to the targets. That's where we look at the solid. So that missiles generally don't go for high cryogenic. Storage facilities, filling, last minute filling operations, leakage, all this liquid and cryos is not used. Coming to the second question, how do we track or see the performance of the missile? We have like 5,000 kilometers away, we keep our ships. 2 ships are kept to track the systems when we are re-entering back the atmosphere. It is re-entering back the black portion, top portion, which contains the avionics and the warhead and all. It goes through kinetic heating, and the outside it becomes, outside is of the order of 2,000 to 3,000 degrees centigrade. And inside, within some 22 mm thickness inside are our avionics, which cannot withstand more than 70 degrees temperature. So that is the RVS structure, re-entry vehicle structure, what I was talking. So that, that with that we have the telemetry system in that. which will be for all demonstration launches or our technology launches, we will have the telemetry system, and ships tracks that and tells us where it has fallen. The onboard telemetry system will be sending the signals. That is for all technological knowledge means launches, what we launch. But systems which are going to the induction doesn't have any telemetry.
But doesn't it burn away while re-entry? How do you prevent it? I mean, elsewhere you have refractories and so on.
That's what I talked about, the RVS structure. That is the magic of the Agni class of systems. The re-entry structure outside goes through a temperature of 2000 to 3000 degrees centigrade, whereas within the 22 mm inside, the temperatures cannot be more than 70 degrees centigrade. So the carbon phenolic, the thermal protection coating is that it has an ablative property. It ablates and goes away. It doesn't allow the temperature to penetrate inside. And structural element is the carbon epoxy part, which holds the structure intact.
Ramesh, go ahead.
Amme, I am Ramesh. I hail from Trichur,
Okay.
Shornur Road.
Sure, no, okay.
Well, out of sheer ignorance, I am asking you, madam, that a few months back we heard through the media that 50 satellites was launched by the students on one day, and it became a record and kind of a thing. Can such a type of thing be possible in your missile technology program also?
Yeah, it is like satellites. We have launched 104 satellites in one single mission by ISRO. So, satellite depends on the nano satellites, the number of satellites, what can be packed into the payload, the launch vehicle capability. Missiles, he asked about multiple re-entry, MARVs, multiple independently targeted vehicles. It can have same Agni type of payloads, 2 of them, 4 of them, multiples are there. Others have demonstrated 12 RVs coming and hitting in 12 different targets can be. Anything is possible.
No, I'm talking about whether the students and all can be used for this kind of record-breaking events like that, what we have.
No,
what we saw.
satellites are launched for the purpose of knowing the technology. Missiles are for hitting a target. Do we need to give it to students? Fine.
No. And one more kuti question is
It's
that.
again a military application. That's when students, if we can take them on board as military majors and colonels, they also can do.
I see. And you have spoken about air to air, air to the surface, then surface to surface and all. Is there anything happening in the water segment of our planet in terms of sending missiles from the submarines to hit some
We
other
have
target?
torpedoes. We call it torpedoes. Underwater, like a missile, is torpedoes. From a ship, it is launched to another
Is
ship.
it being done?
Yeah, it is there. Torpedoes and Vizag Sea. We have torpedoes generated, done for that application.
Go ahead, please.
Good evening, ma'am. Myself, Abdul Rahman. I'm an UPSC aspirant. My question is like, are you belong to bureaucratic or defense family? It's a just basic question. My main question is, on what basis do you develop or upgrade the missiles? You work on demonstration and testing area, right? So once the missile is inducted into the tri-service, so likewise the chopper or the fighter jet or the gun or the tank, you don't use the missile frequently. So on what feedback from the army personnels do you develop or upgrade the missiles?
Yeah, always the feedbacks are for improving the systems. We do the development trials, and when it is fully successful for more than 3 launches consecutively, then only we call it as a successful induction into the services. And from services, they take up the practice launches. thereafter they are doing, and the feedback comes if there is any such
And
feedback.
how often DRDO works collaborate with ISRO?
ISRO not much. Department of Space, this is Department of Ministry of Defense.
Don't you collaborate each other for some projects?
Technological experts and expertise is always common. So rocket technology remains the same as going up. Then guidance schemes differs for each purpose. And launch vehicles to put the rocket onto that particular orbit where it has to be. So the stage rockets are designed to give that final cutoff velocity. Missile, multiple ranges. From this to this, the rocket sizing is, stage sizing is designed based on that. Configuration design is based on that. You asked your first question whether are you diplomatic or bureaucratic family and all those things. My father was an accountant, worked with a private firm. My mother was a qualified teacher, but who didn't work, and homemaker. Yes, I also wrote for the exam for IES, like engineering service. Attending this MTech program, gone for the written test, came back from the Ernakulam railway station, went to the, I think, Maharaja College or somewhere, wrote that exam. But before the result of all those things, I had to go and join back because within a month I had to take a decision. Otherwise, I used to dream of IAS, and these were all part of our life. We can dream of anything, so.
Truly, truly remarkable, ma'am.
Dream has no
Uh, we have a lady speaker. So disappointing that we don't have a question from a woman here. Anyway, sir, please.
So
you want to
while they're thinking about it,
yeah, please go ahead.
I'm sure it'll be well worth the wait. Yeah. Well, thank you, Meenakshi. Ma'am, truly inspiring to hear what you've done, and I'm going away with a sense of pride that in India we have this kind of technology. The making of these missiles, are they public-private partnership? Are they done only by the government? And when you have young people, are they interested in joining the DRDO today? What is the scene?
Yeah, we are at our full strength as far as DRDO is concerned. So initially there was when the IT time people were some people used to quit and go. Salary wise, government salary, now it is fine with the 7th pay commissions, very attractive jobs, and that way it is fine.
And what about the making of the missiles, public-private partnership?
Yeah, today it has come to a private industries have come up or established the capability to build. So machining capability, forging capability has come, and now it is all productions are through private industries. And as on today, we are in, like earlier it was totally government, because infrastructure, the cost of infrastructure required for this missionaries were very high. So government established, and now it is whatever we have the facilities, private industries can come and use. It is in private as well as academic collaborations also. It's a overall knowledge and technology and infrastructure together. So it's open right now.
To quickly add a small point to that question, L&T has a joint venture with an Israeli company, and they have a plant in Coimbatore. They're making missiles. Yes, sir, please.
Yeah, my name is Vasudev. I'm a former chairman, MD of Indian Airlines. At the outset, I would like to express my appreciation for what you have done for this country. It's really remarkable.
Thank you.
And the second question is, I'm a little surprised that they allow people like you to retire. Why is that so? Is there no avenue to retain you in the services of any other organization in the government?
No.
And thirdly, my last question, and do you have any security cover after you retire to make sure that you're protected, you're not abducted and so on? Is there any such thing?
Yeah, when I was 10 years I had this, I think this may not go into recording.
Okay, can we stop the recording now? Please stop it.
Not yet.
Not it got into again ministry. I've been in different forums. I have roles to play. So I'm part of the countries wherever they are. I'm required. My service is required. I'm there.
Madam, I was very curious when you narrated this example of Agni 3 and something went wrong and there was a learning curve there. Like all organizations, do they fix accountability? Because Tamil என்ன சொல்லுவாங்க, something goes wrong. தப்பு எப்படி நடந்தது, யாரு தப்பு பண்ணா?
No,
Does that work in your system or it's innovative?
no, responsibility, fixing the responsibility is there. This is a technological gap. We don't know. Like the computational capability is not existing in the country to compute and say that it can, flow interactions can happen with reverse flow happens and flow interactions happens with it. So the simulation capabilities within the country was not there. Then we could get hold of many systems combined together to get that capability. So
Please,
at
sir,
that
please.
point of time, nobody gives us that type of computers at that. So
Go ahead,
for
sir.
those
Can I?
things we can't call it, can't fix the response. Otherwise, yes, we are all responsible. We can't fail the systems, yes.
My name is Narayan. I work for Asian Development Bank. Firstly, thanks a lot to you, ma'am. We're all indebted to you. My question is a little different, not about technology, but more about the learning that you have been mentioning right from the beginning of your talk. You've been dealing with learning new technologies. I mean, if I could distill a few of them, you talked about aerodynamics, you talked about fluid mechanics, you talked about material science, various things. So how, from your personal experience, how did you manage to constantly learn new things? And what is the approach that you adopted? And what advice could you give to all of us here, including students here, who are starting their careers or who have not even started? So this is...
Yeah, it's like there is no fixed time for me to learn anything. Even at midnight, I'll take journals and go through. It's a passion. How much you read. Now today, if you sit at your own mobile and computers, the amount of knowledge bank. What you want to conceive from that is depends upon you. So interest is like that. Being a project director, techno managerial knowledge has to be there. So you tend to read, and it's a feeling to know more and more. That's the way we learn. And I must say that Dr. Kalam is one person who used to say, we do something, we tell him that we have done and we establish. Don't stop here, he says. You don't stop here. He talks about the newer technologies. So that gives us an inspiration to know about the next technology. So today we think about, today our government initiatives are there to think about technology which can be established another 10 years, 5 years, 10 years, 15 years. Today we are capable enough to think about systems which can work AI based. The computer wherein which we worked, like a typewriting machines, punch cards we have used for computer application, writing programs, Fortran programs, feeding it into and getting the out. I worked with that. Our youngsters won't even know what is that things. Today, you don't need anything. Your palm top with these small things can compute and give you. So you have to know about the system. When-
Thank
Just
you.
so you don't go home with that concern. Dr. Thomas, first of all, thank you so much. I think the enormity of what you have done for this country, really, your appearance belies it. Thank you for the inspiration. But it appears worldwide and certainly in our country, there are not enough girls taking up science. What was different for you? Do you think things are changing? What do you think parents, schools, educators can do differently?
Yeah, it's compared to when I joined engineering, 3% to 15 to 18% today. It has changed over a period of 30 years plus. But it all has to start from your own home. Like when I wanted to go for engineering from within our family, they were saying why the girl has to be sent for engineering. It was not there. So then you have to look for a engineering husband. It becomes, the way thought process is like that. So who will marry? Otherwise, degree, fine. So this thought process has to come from your own home, be it father or mother. Our children should get the education what they want, and they have to be channeled. It is not difficult. Working for some specific projects would have been tough. Challenges were tough. Today it's not like that. We don't have to reinvent the wheel. We'll go above the knowledge what we are having. So then now it is easier. Today is the world to know more about artificial intelligence, machine learning and things like that, which they don't have to break but they have to apply their brain. So that is the way that, but if you ask me to make on that AI, I don't know. This brain doesn't have the capacity to hold it anymore. Whatever is done is done. So the next generation, the field of knowledge is different. So, and their understanding is also at a different level. They can handle multiple knowledge and take on. So that's the way, and we should support. It has to start from the home. You start treating both the children at same par, whether son or girl or boy, give them the same education what they want. So then you will see the difference.
Can I ask the last question? It'll be a software question. So I'm a software engineer. My name is Alok. It seems to me that the control system, the real-time operating system, is the secret thing where you implement the algorithm. If I can understand it like that. It's fascinating. How when you have limited clock speed or cycles in the lower powered CPUs, how you can in that limited amount of time do all the algorithms, the integration that you mentioned about, and still periodically sample all the inputs which are coming from all the sensors. It's a technical question. You need not answer.
When we started the simulation, as I mentioned, it used to take 1 or 2 days to give one particular run executed. Today we have capability to do Monte Carlo simulations and simulations faster, and hundreds of thousands programs executed in in few milliseconds.
Right, but I was talking more about the guidance system rather than the
Guidance system onboard computer is again a microprocessor based
Right.
system. Today we have system on chip. You understand the
Right.
system on chip's capability. So programs are done, the same algorithm supported onto that, and
Okay, but
it does the computations as
but,
fast as
to get the required accuracy, somehow within the time that it is available,
Yeah,
it somehow
that-
computes.
real-time
periodically
structuring is there. Unless otherwise I get a navigation in position input, I won't move on to the control. So like that, it's a
So it's kind of pipeline.
minor cycle, major cycle type of streamlining is put structurally defined where it has to execute, and synchronization between the commands coming.
Right.
All is taken care.
So
Onboard computers are-
my question is there are American company, there is one American company which can land rockets, and it's done so many rockets.
Yeah,
landing.
reusable. They have.
So where is the
done.
gap? That is also some sort of a guidance, right?
Yes, yes. There is no gap. That is another technology. Take the rocket, do the maybe space station activities, and come back. It's again landing back. The missile also coming to the target is again coming back. Similar technologies, you have to bring it back. There's nothing.
No, but nobody else has done it. So the
Yes,
curiosity
rocket
is,
reusable rockets are started coming. So that they also started doing it 10 years before only. So maybe if it is a requirement, it will cost benefit. It may come back to us also.
okay.
Super. So can we? I have to stop it for the simple reason she has a 10 o'clock flight to catch to Bangalore. Look at her simplicity. Huh?
Yeah, I have to get.
She doesn't even know that the flight is at 10 o'clock. No, because she told
Anand,
me.
did you have to remind her about it?
I didn't want to, but normally we stop at 7:30, but this can go on. I'm absolutely sure that all of us are really fascinated with this story. We can go on. But considering Chennai traffic and the uncertainty, she has to head. And look at her simplicity. When I told her, Madam, we usually end at 7:30, your flight is at 10 o'clock. What about dinner? Anand, just leave it. I'll manage. Why are you getting? You know, high achievers are very simple people. Very clearly demonstrated by this president. More than one reason. And the other factor which clearly came out is no PowerPoint presentation, not even a slip of paper for reference. It was just pouring her heart out about what she achieved over a period of 34 to 38 years. And I think this is the only event in 169 events so far where he had no PowerPoint presentations and no reference material. Just speech and conversation. Maybe we should go back to this model which is more effective. I don't know. I don't want to jump the gun and pass a conclusion on that. But really, Madam, we are thankful on behalf of the Board of Directors and all the members of CIC for you to have come all the way to Bangalore to narrate this story. I wish the hall were full, but people who did not attend, I didn't want to complete that sentence. You have done it. But they can look at it in the YouTube. Yeah, it will go on YouTube. No, I know, but it's not all. But that's okay. But nothing like hearing it like this live. That is the thrill of that is really something to be savored and cherished. And Ramesh, I must really thank you. I know I should not be taking you for granted. I mean, you have done so much in your career in this field, and you deserve all our applause for the way you have conducted this particular proceedings. No. Plus, this is a very technical subject, so you need somebody with that frame of mind to ask the probing questions that you did.
Yeah. So I'm also going back knowledgeable with Patna. Yeah.
No, but somewhere I am now thinking, I don't know, all of you will have to provide inputs. I'm very happy, Mr. L. Vasudev is here. I have heard a lot about you, sir. We never even knew. Please stand up, sir. I would like people to know. He was the chairman and managing director of Indian Airlines in 91.
It's a familiar
92.
name. Put a face to it now.
And he was originally in Madras Fertilizers Limited, if I remember right, yes. So very happy to see you, sir. So we have to conclude this session. But I don't know whether like Indian 1 and Indian 2 or whatever sequel, we should have a sequel to this also. In a much more detailed manner. Ramesh also is affirming it. We'll have to do it in a much more structured format so that more people benefit out of this particular interaction. So thank you one and all. And our July programs are also getting final now. It will be announced. Please support us by coming in large numbers. Thank you very much.
Thank you.
Her next topic will be gyroless inertial navigal system.
That I can teach for months together. Thank you.